Okay, and it's called empirical formula, but there's no real actual formula. You just have to kind of remember how to do it, okay? So I'm going to walk you through it. Now, your whole objective is to figure out specifically how many elements do you have of each element that they're giving you. All right, now don't forget you need to use the periodic table. If you don't have one, you can use the book cover, okay? So now, for this, the first thing you're going to do is you're going to divide by the total molar mass of that particular element. So what's my molar mass for copper?
63.546.
Okay, so we can do 63.5 or we can do 64, right? Okay. Now, what's my molar mass for bromine?
79.9.
Okay, so yes, and we can round that off to 80. Okay, so now this is your first part. Now, this next part is important because you have to give me at least 3 significant figures. So for copper, you're going to divide 28.4 divided by 63.5, and you're going to give me at the very least 3 numbers. Okay, so go ahead and divide it. And what are your 3 numbers? 0.447. Okay, and what's the number after the 7?
2.
Okay, so 0.447 is your most that you can round off, right?
Yes.
Okay, so now go ahead and do bromine. 71.6 divided by 80, and give me 3 numbers. 0.895. Yes? Okay, now you're going to do this to, it doesn't matter how many elements you have. You can have 9 or 10, but you're going to do that to all of them, okay? Now, look at your 2 numbers. Which is your smallest number?
Copper.
Yep. So you're going to divide all of them by the 0.447, and I'm running out of space there, 0.447. Now, this is very important. You can't round off there. You can't just have 0.4 or 0.5. You must have the 3 numbers, okay? If not, your chemical will come out wrong. So now, go ahead and divide that. 0.447 divided by the 0.447 is going to give you how much? 1. Very good. Now, this last part, you can round off. Okay, now do the second one, 0.895 divided by the 0.447.
2.002.
Okay, let me put that over here. 2.002. So this we can round it off to what?
2.
To 2, okay? Now this is very important because these numbers are going to tell you how to write your chemical formula, okay? So let's say we had 2.4. What can that round off to? To 2, right? Okay, what if I had 2.8 or 2.9? That would round off to 3. Very good. Okay, now what's different is what if I had landed at 2.5? When I have a 0.5, you can't round off, okay? And I'm going to tell you why. When you have your periodic table, can I have a nitrogen 2.5? I can't have half an atom, right? Okay, so only when it lands on the 2.5, you're going to multiply times 2. So 2.5 times 2 would have given me 5, and this would have been for bromine. But what you do to one, you must do to the other. So then copper would have been times 2 as well, and this would have been 2, okay? But we didn't get 2.5, right? So let's go ahead and erase that. Okay, and we're not going to do that. But that's just for future reference, because if you do get something like that, then yes, if you get the 1.5, it's going to be different. Okay?
Is that how we're going to write it down?
No. So what this means right here is that you have 1 copper and you have 2 bromines. Okay? So this right here, this is your empirical formula. Okay? Because can I have different chemicals with the same elements? Could I have like a copper Br3? Yeah. Or I could have a CuBr where copper's just 1, right? Same thing. Like if I had water, if I have H2O, I can still have the same elements, and I can have H2O2, but that's hydrogen peroxide, right? It does make it a different chemical, but can I have the same elements in different types of formulas? Yes, okay? And so this is going to tell you exactly, specifically, how many of each elements you have. And that's the whole objective here, is you're going to figure out exactly how many coppers you have and how many bromines you have. And this is an extension to the percent composition that we did the past 2 days. Okay? Yes? Are we all good? Okay, now there's an easier way also. What if I give you a molecular formula? Let's look at the bottom of your worksheet. And on the molecular formula down here, look at, let's do letter A. Can I reduce all of that by a number? Okay, we could do 2 or 6. So if we reduce by 6, 6 divided by 6 gives you how many carbon? 1, very good. Hydrogen, if I reduce 12 divided by 6 gives you how many? 2, very good. And then oxygen would give you 1, very good. Now, once you have this answer, your empirical formula, can I reduce that any further? No, you can't. So that's how you know that's the lowest mole ratio that you can have. That's your actual empirical formula. Okay? Huh? What was that question?
That's the common factor. The common factor is 6.
Let's do one more just in case, okay? Let's do another one. Let's say I give you something like C12. I'm just making stuff up, okay? H22, and let's say O16. Can I reduce that?
2.
We can divide by 2, yes. So C6, H11,
Oxygen.
Oh, 8.
O8, very good. Now look at your empirical formula. Can I reduce it anymore?
Nope.
No, because of that 11, right?
Yeah.
Okay, so that would be your lowest mole ratio, and so that is your empirical formula. Okay, is that a little better?
So if our
Yes?
empirical formula can be reduced, we reduce it even more.
Right. So let's say let's just pretend instead of that H being 11, let's say it was a 12. Can I reduce it now? Yes.
If you can't reduce it,
So-
you can do the whole thing right here.
Then that's your empirical formula.
So if you can't reduce
Like if you can't reduce it anymore, that's where you stay. That's your empirical formula. Okay? So here for the C6H12O8, that would reduce to what?
C and H.
Let's divide by 2. 6 divided by 2? 3. Hydrogen would be 6. And oxygen would be, yep. Now can I reduce further? No. So then this would be your most reduced, and that would be your correct format. We see that? Yes? Is anybody unclear? Do we have a question? Yes?
So the Fe2O3, since you can't divide 3 by anything,
Right.
you just leave it.
That's your most, that's your lowest formula, yes. That's your most reduced. Very good.
Do not reduce the Fe.
No, if you can't reduce it, then it stays that way.
So if you can't reduce, even if it's just 1.
Right, then you can't reduce the whole thing. Very good. That's a very good question. Did you hear what she said? If you have, and that's what happened to us on the previous one, right? We weren't able to reduce because of the 11 that was here. Okay, so that means this is the empirical formula because we cannot reduce all of them. Okay? And so the 6 and the 8, even though you can reduce that, because of the 11, this whole thing is your most reduced compound, and that's your empirical formula. That's good. Okay? All right, let's go back to the top. Let's do one more of those. Are we okay? Do we have any questions? Huh? Do we need another example? No? Are we sure? We're good?
You're dividing everything by the you're dividing them by the smallest one?
Yes. Mm-hmm. Okay, and it doesn't, like, on that number 2, you have 4 elements, right?
Mm-hmm.
So, let me just erase the stuff from before. So, yes, you would have to first divide by its own molar mass, okay? So K would be divided by 39. Carbon's going to be divided by what? 12, very good. Hydrogen would be 1. Oxygen would be what? 16. Now, the middle part, this is your most important part, because you must have how many numbers? You must have the 3. Mm-hmm.
Does the 3 numbers have to be after the decimal or just in total?
In total significant figures. So remember, if you have a 0 point something, that 0 does not count as a real number.
What if you have like 0.057? Will the 0 count, or would you have to add
If you have a 0.057 like this,
yes, would that
then
count?
the 0, remember that your first number, significant figure, counts after the first real number.
Okay.
So you said that.
And so, yeah, so you would have to have one more number.
Okay. So
Okay.
the 0 doesn't count.
Like, it's not that the 0 doesn't count, it does, but it has to be after a first real number.
So like if it
Like
was
1 through 9.
0.507, it'll be okay.
Yes, uh-huh. Okay.
How'd you get the 0.5?
No. That guys, we were talking about something else. That is not for number 2.
Wait, but number 2, you said you have to have at least 3 numbers.
Yes.
But all on number 2, it's all 1 and then 3.
Okay, so just for like placement purposes, you can put 1.00. Okay. So I see what you mean. Like here you have 12 divided by 12. 1.00 reminds you must have 3, right? And then here you would have 1.01. And then what's your oxygen? Yep, 2.99. So what's your smallest number there?
1.
Yep, so you're going to divide everything by 1. So now, how many
1,
potassium are you going to have? 1.
1,
1. And hydrogen? How much would hydrogen be? 1, very good. And oxygen would be? 3, very good. So what's my empirical formula? What did you get for that?
KCHO3.
Yep, and that is correct. Okay? That's it. Okay, are we all good?
Yes, ma'am.
Yes? No more questions? Okay. All right. If you get stuck somewhere, you're going to let me know.